All right, welcome back. This is part 2 of the video series on solving systems of equations. In this video, I'm going to show you how to use the elimination method to solve systems of 2 equations and 2 variables, as well as systems in 3 equations with 3 variables. Remember, the elimination method is sometimes called the linear combination method, because we're essentially combining 2 equations with the intention of eliminating one of the variables, so we have one equation and one variable that we can isolate and solve for. So if I take a look at the given system, I've got x minus 4y equals 4 and 5x minus 8y equals 20. The goal, again, is to eliminate one of the variables. It doesn't matter which variable you choose to eliminate first. I could choose x or y. It really doesn't matter. Sometimes it makes more sense to eliminate a certain variable first, depending on what it's going to take to eliminate that variable. In this case, either variable is going to be very simple to eliminate. For example, if I wanted to eliminate my y variable, I need to have opposite coefficients. So right now I have a 1x and a positive 5x. They don't cancel right now. If I were to combine the 2 equations, I'd end up with 6x, not 0. If I want 0, then I need there to be a negative 5 there. But if I put a negative 5 there, that means I also have to distribute that negative 5 across both sides of the equation. And if I do that, that would leave me with a negative 5x. Don't forget, when you multiply a negative 5 times a negative 4y, that's going to give you a positive 20y, because your sign is going to change. You also don't forget to multiply times the other side of the equation as well. So negative 5 times 4 is going to give you negative 20. At this point, now I have opposite coefficients in front of x. I've got a positive 5x and a negative 5x. When I add a positive 5 to a negative 5, I get 0 x's left, which means I'm not even going to write the x variable down. I'm going to go ahead and combine these 2 equations by adding up the terms. So the 5x, the negative 5x, we said that's going to cancel. A negative 8y and a positive 20y, when I put them together, is going to give me 12y. And my 20 and negative 20 are going to cancel to 0. Okay, so now we're down to the point where we have one equation with a single variable, which is great because now we can actually solve for y. What I did notice, though, on the last quiz that we had was that when students got to this point where they had something equals 0, they thought that meant that there was no solution. Notice that my y variable did not cancel out. The only time that you're not going to have a solution is when both x and y cancel out to nothing, and then you're left with a different number on the other side. In this case, if I have 12y equals 0, so if you have 12 y's and their total quantity equals 0, that means that each y is also equal to 0. Because if I divide both sides by 12, well, 0 divided by 12 is just 0. Okay, so don't be afraid just because you get 0 on one side doesn't necessarily mean that there's no solution or infinite solutions. The only time that would happen is if both variables canceled, and that didn't happen here. I still had 12 y's left. Once you know the value of one variable, you can plug it in to find the value of the other. I'm going to go ahead and just plug this into my first equation. So remember, we had x minus 4 times y is equal to 4. And I'm just going to replace the y with 0. And so negative 4 times 0 is 0, and so I'm basically left with x equals 4. So my solution here is going to be 4, 0. If I had decided to eliminate y first instead of x, let me just show you what that would look like. So I'd still have my equations, x minus 4y equals 4, and I'd have 5x minus 8y equals 20. So let's say we decide to eliminate the y variable first. If I want to eliminate y, that means that I need to, again, have opposite coefficients in front of y. Well, 4 goes into 8 evenly, so that's perfect. But what I would like is to transform the negative 4 into a positive 8, because if I have a positive 8y and I combine it with a negative 8y, then I know the y's are going to cancel. So I need to think to myself, what do I need to multiply negative 4 by to get positive 8? Well, I need a negative 2. So I'm multiplying both sides of my equation by negative 2. And so I'm going to distribute the negative 2 to each term. That's going to give me a negative 2x. That's going to give me a positive 8y. And that's going to give me a negative 8 on the other side. Now when I combine, again, I'm combining those 2 equations. I'm adding them together. A 5x and a negative 2x is going to give me 3x's. Negative 8y and positive 8y means those are going to cancel. And 20 and a negative 8 together are going to give me 12. When I divide both sides by 3, I get that x equals 4. And that's what we got the last time. Now that I know what x is, if I plug it back into one of my equations, I can solve for y. I'm going to go ahead and plug it into the first equation. So I know that 4 minus 4y is equal to 4. And if I'm solving for y, that means I'm going to need to subtract that 4 from both sides. That means I'm going to be left with a negative 4y, because these 4's are gone, and that's going to equal 0. And again, remember, if negative 4y equals 0, I can still divide by negative 4 to get y by itself. And 0 divided by negative 4 is just 0. So notice that it doesn't matter which variable we eliminate first. We still come up with the same solution. The next example I'm going to do is going to be a system with 3 variables. And these take quite a bit of time to solve. The easiest thing to do is to label your equations 1, 2, and 3. And the strategy is to eliminate one variable at a time. So I'm going to decide which variable I want to eliminate, and then what I'm going to do is I'm going to combine 2 of my equations at a time and reduce them to 2 equations and 2 variables. Because once I have 2 equations and 2 variables, I know what to do. So just to make it easy, I'm going to go ahead and attempt to eliminate my x's. And remember, I want to eliminate the same variable in each case. Since my coefficient in number 3 is just 1, I'm going to combine my second and third equations and my first and third equations together, because it's going to be easiest for me to eliminate the x's by multiplying that third equation by either a negative 2 or a negative 3. So let me go ahead and start with my first and third. So I had 3x plus 3y plus 6z equals 9. If I want to eliminate x, then I need to transform that third equation. I need there to be a negative 3 in front of x. And that will enable me to eliminate x in this equation. So I'm just going to put this here, and I'm going to multiply everything by negative 3. When I distribute the negative 3, that means this is going to be negative 3x. This is going to become negative 6y. This is going to become a positive 3z, because remember, a negative 3 times a negative 1z is going to give me a positive 3z. And on this side, I'm going to have a positive 30. Negative 10 times negative 3 is positive 30. When I add the 2 equations together, x is gone. I'm left with a negative 3y plus 9z is equal to 39. I'm going to label this equation 4. So what I just did is I combined equations 1 and 3. What I want to do over here is combine equations 2 and 3. So equation 2 was 2x plus y plus 3z equals 7. And again, I want to eliminate the same variable. I want to eliminate x again. But this time, if I want to eliminate x, I need the coefficient of this x to be negative 2. So instead of multiplying by negative 3, I'm going to multiply through by a negative 2. And if I distribute that negative 2 across the entire equation, that's going to give me a negative 2x, a negative 4y, a positive 2z, and a positive 20. And now I can add the 2 equations together. Because I have opposite signs there, my 2x and negative 2x cancel. I'm going to have a negative 3y plus 5z is equal to 27. And I'm going to call this equation 5. The benefit to eliminating x in both pairs is that now I'm left with 2 equations in 2 variables, and the variables are the same in both. So now the goal is to combine equations 4 and 5. So if I take a look, here's my equation number 4. I'm just going to write 5 right underneath it. And obviously, I think it's going to be easiest to eliminate my y variable because the coefficients are almost opposite. If they're both negative 3 at this point, they're not going to cancel because when I put them together, I'm going to get negative 6. So what I'd like to do is multiply one of the equations by negative 1. I'm going to go ahead and just do that to the first equation. And I'm going to rewrite it underneath. If I multiply negative 3y times negative 1, I get a positive 3y. 9z times negative 1 is going to give me a negative 9z, and 39 times negative 1 is going to give me a negative 39. Now when I combine these 2 equations, my y's now cancel. I'm left with a negative 4z and that's going to equal negative 12. And so to solve, I'll divide both sides by negative 4, and I find that z is equal to 3. Now that I know what z is, I can solve for y. And what I'm going to do is use either equation 4 or equation 5, since both of those equations only involve y and z. So if I know the value of z, I can easily find the value of y. So I'm going to plug the z in to the to the fifth equation. And so that means I'm going to have negative 3y plus 5. I'm replacing the z with a 3, and that equals 27. So if I simplify, I have negative 3y plus 15 equals 27. And if I subtract 15 from both sides, I get that negative 3y equals 12. And if I divide both sides by negative 3, I get that y is equal to negative 4. So now I have a value for z and y. The last step is to find the value of x. So I'm going to go ahead and just use my first equation, which is right here, where I had 3x plus 3y plus 6z equals 9. Let me give myself a little bit of space. I'm not sure what just happened. Let me see if I can go back. Okay, I don't know what just happened. All right, so we said the equation was 3x, let me just write it down, plus 3y plus 6z equals 9. And I know the value of z and y. So I'm going to replace them. So I know I'm still going to have the x, but now I'm going to have 3 times y, which is negative 4, plus 6 times z, which I know is 3, and that's got to equal 9. And so when I simplify, I'm going to have 3x, 3 times negative 4 is negative 12, 6 times 3 is 18, and that's going to equal 9. I'm going to go ahead and combine my numbers, and that's going to be 3x. Well, negative 12 plus 18 is 6, and that's going to equal 9. If I subtract 6 from both sides, I get that 3x is equal to 3, and if I divide both sides by 3, I get that x equals 1. And so my solution, if I write it as an ordered triple, is 1, negative 4, and 3. And there you go. Stay tuned for solving systems using matrices.